A term sheet is like a menu that tells the entrepreneur what the investor wants in exchange for money. It is non-binding except for a few sections: confidentiality, exclusivity, and governing law. The most common provisions are valuation, the price the investor assigns to the whole company. It can be expressed as pre-money value before the new cash or post-money value after the cash. Example, a startup is valued at 10 million pre-money and an investor puts in 2 million. Post-money equals 10 million plus 2 million equals 12 million. Equity stake, how much of the company the investor will own after the round. Formula: stake equals investment divided by post-money. Using the numbers above, stake equals 2 million divided by 12 million equals 16.7% of the fully diluted capital. Liquidation preference determines who gets paid first if the company is sold or liquidated. The most basic form is 1 times non-participating. The investor receives an amount equal to the investment, here 2 million, before any proceeds go to common shareholders. If the exit is 5 million, the venture capital gets 2 million, and the remaining 3 million is split among all shareholders proportionally. Anti-dilution protects the investor if a later round is priced lower. The two most common methods are full ratchet and weighted average, explained later. Voting rights, usually investors receive 1 vote per share of preferred stock. Some term sheets grant veto rights on major actions such as sale greater than 50 million, new debt greater than 5 million, change of control, and so on. Board composition, the term sheet often specifies how many board seats the investor gets. A typical early-stage venture capital may ask for 1 out of a 3-seat board, with the remaining seats held by the founders and an independent director. Vesting, founders and key employees must keep their equity over time. A standard vesting schedule is 4 years with a 1-year cliff. The term sheet may require that any unvested founder shares be repurchased by the company at a nominal price if the founder leaves. Other clauses, right of first refusal, co-sale rights, also called tag-along, drag-along rights, information rights, and redemption rights. These clauses dictate who can buy shares later, how exits are handled, and what information the investor receives. The term sheet is a negotiation tool. Once both sides agree, the legal documents such as stock purchase agreement, amended and restated certificate of incorporation, and others are drafted to reflect the agreed terms. Explanation: the difference between pre-money and post-money valuation is the cash that will be added by the new investors. Formulas: pre-money valuation V pre equals post-money valuation V post minus new investment I. Post-money valuation V post equals V pre plus I. Investor ownership percent equals I divided by V post. Founder dilution equals 1 minus V pre divided by V post. Numerical examples. Suppose a startup has existing shareholders, founders plus early angels own 100% of the equity. Pre-money valuation equals $8 million. The company raises a Series A round of $2 million. Step 1. Compute post-money valuation. V post equals $8 million plus $2 million equals $10 million. Step 2. Compute the new investor's equity stake. Stake A equals $2 million divided by $10 million equals 20% of the fully diluted company. Step 3. Compute founder dilution. Founders now own 80%, which is $8 million divided by $10 million. What if there is an existing option pool? Assume a 10% option pool was already created on a fully diluted basis before the round. The pool already represents 10% of V post, so the founder's effective ownership after the round is 70%, 80% times 0.875, and the pool remains 10%. Multiple rounds illustration. Seed round, $1 million at $4 million pre-money. Post-money $5 million, seed owns 20%. Series A, $3 million at $12 million pre-money. Post-money $15 million, A owns 20%. Series B, $5 million at $25 million pre-money. Post-money $30 million, B owns 16.7%. Cumulative dilution can be tracked by multiplying the surviving percentages after each round. Founders after seed equals 80%. After Series A equals 80% times 12 divided by 15 equals 64%. After Series B equals 64% times 25 divided by 30 equals 53.3%. These simple formulas let you see exactly how each financing event shrinks the original owner's slice of the pie. Explanation: a liquidation preference tells investors how much they get back before any money goes to common shareholders when the company is sold, liquidated, or goes public. Three common structures are: straight non-participating preference dash, the investor receives either the preference amount or converts to common and participates with the other shareholders whatever is higher. Formula: payout equals maximum of preference and pro rata share of exit. Participating preference full participation dash, the investor first gets the preference amount and then participates pro rata with the remaining proceeds just like common stock. Formula: payout equals preference plus investor percent times exit minus total preferences paid. Participating preference with a cap or multiple dash, the investor can participate only up to a multiple of the original investment, for example 2 times. After the cap is reached, the investor behaves like a non-participating holder. Step-by-step payoff example. Assume a company exits for $30 million. Preferred Series A: 2 million shares, $1 million investment, 1 times non-participating. Preferred Series B: 3 million shares, $3 million investment, 1 times participating. Common founders and employees: 5 million shares. Total shares fully diluted equals 10 million. Straight Preference Series A. Preference equals $1 million the amount invested. If the pro rata share of $30 million would be 2 million divided by 10 million times $30 million equals $6 million, the investor chooses the higher, i.e. $6 million, and converts to common. Participating Preference Series B. First pay the preference $3 million. Remaining pool equals $30 million minus $3 million equals $27 million. Investors' ownership after conversion equals 3 million divided by 10 million equals 30%. Participation amount equals 30% times $27 million equals $8.1 million. Total payout to Series B equals $3 million plus $8.1 million equals $11.1 million. Cap example: 2 times cap on Series B. Maximum payout allowed equals 2 times $3 million equals $6 million. Since the calculated $11.1 million exceeds the cap, the investor receives $6 million, and the excess $5.1 million is distributed among common shareholders. These calculations illustrate how the type of preference dramatically changes the cash each stakeholder receives at exit. Anti-dilution provisions adjust the conversion price of preferred shares when the company later issues shares at a lower price, a down round. 2 main methods are used. Full ratchet anti-dilution. The conversion price is reset to the price of the new round, regardless of how many shares are issued. Formula: new conversion price equals price of new round, pay new. Effect: preferred shares become more valuable. Investors receive extra common shares to keep their ownership percentage. Example: original Series A, 1 million preferred shares, conversion price $5 per share, that is, each preferred can be converted into 1 common share at $5. New down round, investors purchase 2 million new shares at $2 per share. New conversion price equals $2. Each series of preferred now converts into $5 divided by $2 equals 2.5 common shares. Additional common shares received equals 1 million times 2.5 minus 1 equals 1.5 million shares. Ownership of Series A investors rises from 33.3%, 1 million divided by 3 million, to 45.5%, 2.5 million divided by 5.5 million. Weighted average anti-dilution, the most common, considered fairer. Adjusts the conversion price based on both the price and the size of the new issuance. Formula: broad-based weighted average. New conversion price equals old conversion price multiplied by the sum of old shares and the product of new shares and new price divided by old conversion price, all divided by the sum of old shares and new shares. Derivation: it treats the new shares as adding value to the existing pool, spreading the dilution proportionally. Numeric example: Old 1 million preferred shares, conversion price $5. New down round, 2 million shares at $2. Plug into formula. Numerator equals $5 times open parenthesis 1 million plus open parenthesis 2 million times $2 divided by $5 close parenthesis, which equals $5 times open parenthesis 1 million plus 0.8 million close parenthesis, equals $5 times 1.8 million, equals $9 million. Denominator equals 1 million plus 2 million equals 3 million. New conversion price equals $9 million divided by 3 million equals $3 per share. Each old preferred now converts into $5 divided by $3, approximately 1.667 common shares. Extra common shares equals 1 million times open parenthesis 1.667 minus 1 close parenthesis, approximately 0.667 million. Ownership rises from 33.3% to open parenthesis 1 million times 1.667 close parenthesis, divided by open parenthesis 1 million times 1.667 plus 2 million close parenthesis, which equals 1.667 million divided by 3.667 million, approximately 45.5%, less aggressive than full ratchet but still protective. Both methods preserve investor value, but full ratchet can be harsh on founders, while weighted average balances interests of new and existing shareholders. Key takeaway: when you see an anti-dilution clause, write down the formula, plug in the numbers, and you will instantly see how much ownership a prior investor will retain after a down round. Vesting is a way to make sure founders and key employees stay with the company long enough to earn their equity. The most common schedule is 4-year vesting with a 1-year cliff. Cliff: no shares vest during the first year. At the 12-month mark, 25% of the total grant vests all at once. Monthly or quarterly vesting thereafter. The remaining 75% vests evenly over the next 36 months or quarters. Numeric illustration. Assume a founder receives a grant of 1 million shares representing 40% of the company before any financing. The schedule is 4-year with a 1-year cliff. Time: shares vested, percent of grant vested, percent of total company pre-financing. 0 months, 0 shares, 0%, 0%. 12 months cliff: 250,000 shares, 25%, 10%. 24 months, 500,000 shares, 50%, 20%. 36 months, 750,000 shares, 75%, 30%. 48 months, 1 million shares, 100%, 40%. If the founder leaves before the cliff, for example after 8 months, they walk away with 0 shares. The company can reallocate those shares to the option pool or new hires. When the cap table is shown on a fully diluted basis, unvested shares are still counted as outstanding because they are part of the option pool. After the cliff, the founder's effective ownership jumps from 0% to 10% of the total. This sudden increase can be visualized as a step function on a graph of ownership versus time. Why the cliff? It protects the company from giving away equity to people who leave early. Why the cliff? It aligns incentives. Founders must survive the first risky year to keep any equity. Variations. Backloaded vesting, for example 3-year vesting with a longer cliff, is used for later stage hires. Variations. Performance-based vesting ties some shares to hitting milestones such as revenue, product launch, etc. Understanding the math behind vesting helps you forecast how much equity each person truly owns at any point, which is crucial for dilution planning and for answering exam questions that ask for effective ownership after a certain period. Explanation. A cap table, capitalization table, is simply a spreadsheet that lists every security holder, the type of security they own, common, preferred, options, warrants, the number of shares, and the percentage ownership on a fully diluted basis. Section 1. Building a simple pre-round cap table. Suppose a startup has founders 4 million common shares, 80% of fully diluted. Early angel 0.5 million common shares, 10%. Option pool reserved, not yet granted, 0.5 million shares, 10%. Shareholder column, shares column, percent fully diluted column. Row 1, founders 4 million shares, 80%. Row 2, angel 500,000 shares, 10%. Row 3, option pool 500,000 shares, 10%. Row 4, total 5 million shares, 100%. Section 2. Adding a new investor, Series A, $2 million at $8 million pre-money. Post-money valuation equals $8 million plus $2 million equals $10 million. New investor gets 20%, $2 million divided by $10 million per share price. To keep the option pool at 10% after the round, we must refresh it. Desired pool equals 10% of new total shares. Step-by-step calculation. Step 1. Existing shares before round equal 5 million. Step 2. New investor shares equal 20% of post-money shares. Let X be total post-money shares. 20% of X equals 2 million divided by 10 million per share price, which is 0.2x. Actually, we compute using ownership. Investor percent equals investment divided by post-money, 20%. So total post-money shares equal existing shares divided by 1 minus investor percent. 5 million divided by 0.8 equals 6.25 million. Step 3. Investor receives 6.25 million times 20% equals 1.25 million new shares. Step 4. New total before pool refresh equals 5 million plus 1.25 million equals 6.25 million. Step 5. Desired option pool equals 10% of final total. Let final total be T. 10% of T equals option pool. We already have 0.5 million reserved, so we need to create extra shares equal 10% of T minus 0.5 million. But T equals 6.25 million plus new pool shares. Solving, 10% of 6.25 million plus new equals 0.5 million plus new. This gives 0.625 million plus 0.1 times new equals 0.5 million plus new. Subtracting gives 0.125 million equals 0.9 times new. Therefore, new equals 0.1389 million, approximately 139,000 shares. Step 6. Final total shares approximately 6.25 million plus 0.139 million equals 6.389 million. Step 7. Revised ownership percentages. Founders 4 million divided by 6.389 million equals approximately 62.6%. Angel 0.5 million divided by 6.389 million equals approximately 7.8%. New investor 1.25 million divided by 6.389 million equals approximately 19.6%, close to 20% after rounding. Option pool post-refresh 0.639 million divided by 6.389 million equals 10%. Section 3. Reading the cap table. Authorized shares. Maximum the charter allows, for example, 10 million. The cap table shows how many are issued and how many remain. Issued versus reserved. Issued equals shares already granted, reserved equals shares set aside for future grants. Option pool. Fully diluted includes all shares that could exist after all options, warrants, and convertible securities are exercised. A well-structured cap table helps founders see how much ownership they will retain after each financing, and makes it easier to negotiate terms with investors. Cap tables are not static. They evolve with every financing round, option pool refresh, and conversion event. A pro forma cap table projects the future ownership after planned rounds, allowing founders and investors to see the dilution path. Below is a simplified 3-round scenario, seed to Series A to Series B, with a 10% option pool maintained after each round. Seed round, pre-money valuation $4 million, new money $1 million, new shares issued 1 million shares at $1 price. Option pool refresh 0.2 million shares to reach 10%, total shares after round 5 million shares consisting of 4 million founder shares, 0.5 million angel shares, 0.5 million pool shares, and 1 million seed shares. Founder 80%, angel 10%, seed venture capital 0%, Series A venture capital 0%, Series B venture capital 0%, option pool 10%. Series A round. Pre-money valuation $12 million, new money $3 million, new shares issued 2 million shares at $1.5. Option pool refresh 0.3 million shares to keep pool at 10%. Total shares after round 7.3 million, founder 54.8%, angel 6.8%, seed venture capital 13.7%, Series A venture capital 27.4%, Series B venture capital 0%. Option pool 10%. Series B round. Pre-money valuation $30 million, new money $5 million, new shares issued 3 million shares at $1.667. Option pool refresh 0.4 million shares, keeping pool at 10%. Total shares after round 10.7 million, founder 37.4%, Angel 4.7%, Seed Venture Capital 9.3%, Series A Venture Capital 17.8%. Series B Venture Capital 25.2%, Option Pool 10%. How the numbers are derived. Step 1, Seed Round, Pre-money $4 million, New Cash $1 million leads to Post-money $5 million. Issue 1 million shares at $1 each. To keep a 10% pool after the round, add 0.2 million shares because 10% of 5 million is 0.5 million total pool. 0.5 million already existed, so add 0.2 million. Step 2, Series A, existing shares equal 5 million. Desired post-money ownership for new investors equals 3 million divided by 12 million plus 3 million, which is 20%. Solve for total shares after issuance. 5 million divided by 1 minus 0.2 equals 6.25 million. New shares needed equals 6.25 million minus 5 million, which is 1.25 million. However, we also need to increase the option pool to 10% of the future total, approximately 0.625 million. Existing pool is 0.5 million, so add 0.125 million. Rounding gives 2 million new shares including the pool refresh as shown. Step 3, Series B, repeat the same steps. Compute total post-money shares, issue new shares for the $5 million investment, then top up the pool to 10%. Key insights for students. Cumulative dilution. Founder ownership drops from 80% to 54.8% to 37.4% across 3 rounds. A typical pattern. Option pool refresh. Every time the pool is topped up, all existing shareholders are diluted a little more. Investor stakes. Earlier investors, seed, often end up with a larger percentage of the final company than the amount they invested because they benefit from lower prices and anti-dilution protections. Pro forma use. Before negotiating a new round, founders build a pro forma table to see whether the proposed price and pool size will leave them with enough equity to stay motivated. By constructing these tables step by step, you can answer most exam questions that ask for post-round ownership or total dilution after N rounds. Ownership calculation. A startup raises a series a round of $4 million at a $16 million pre-money valuation. What percent of the company does the Series A investor own after the round? Assume a 10% option pool is created post-money. Post-money equals 16 million plus 4 million equals 20 million. Investor percent equals 4 million divided by 20 million equals 20%. To have a 10% pool after the round, total shares equals existing divided by open parenthesis 1 minus 20% minus 10% close parenthesis equals existing divided by 0.7. The pool adds dilution to all existing shareholders. Liquidation preference payouts. Company exits for $50 million. Capital structure: 2 million Series A preferred 1 times non-participating, 1 million Series B preferred 1 times participating, 3 million common. Compute cash each class receives. Series A gets $2 million its preference. Remaining equals $48 million. Series B participates. First gets its $1 million preference, then shares the remaining $47 million proportionally. Total shares after conversion equals 2 million plus 1 million plus 3 million equals 6 million. B percent equals 1/6. So participation equals 1/6 times $47 million, approximately $7.83 million. Total B payout equals 1 million plus 7.83 million equals $8.83 million. Common receives the rest. 50 million minus 2 million minus 8.83 million equals $39.17 million. Split 3 million over 3 million equals 13.06 million each if there are 3 founders. Weighted average anti-dilution adjustment. Series A investors bought 1 million shares at $5 each. Later, the company issues 2 million shares at $2 each. Compute the new conversion price for Series A using the broad-based weighted average formula. New conversion equals open parenthesis 5 times open parenthesis 1 million plus open parenthesis 2 million times 2 divided by 5 close parenthesis divided by open parenthesis 1 million plus 2 million close parenthesis equals open parenthesis 5 times open parenthesis 1 million plus 0.8 million close parenthesis divided by 3 million equals open parenthesis 5 times 1.8 million close parenthesis divided by 3 million equals 9 million divided by 3 million equals $3 per share. Vesting impact on effective ownership. Founder A receives 800,000 shares with a 4-year vesting schedule and a 1-year cliff. After 18 months, how many shares are vested? What percent of the total 5 million share company does that represent? After 12 months, 25% vests equals 200,000 shares. The next 6 months vest monthly. Open parenthesis 800,000 minus 200,000 close parenthesis, divided by 36 approximately 16,667 per month. For 6 months equals 100,000 additional shares. Total vested equals 300,000 shares. Ownership equals 300,000 divided by 5 million equals 6%. Pro forma cap table after multiple rounds. Starting cap table: founders 70%, angel 10%, option pool 20%, open parenthesis 10% granted, 10% reserved close parenthesis. Series A invests $5 million at a $15 million pre-money valuation and demands a 15% option pool post-money. Compute the post-series ownership percentages. Post-money equals 15 million plus 5 million equals 20 million. Investor percent equals 5 million divided by 20 million equals 25%. Let existing shares equal 100 for simplicity. After round, total shares equals 100 divided by open parenthesis 1 minus 0.25 close parenthesis equals 133.33. New investor gets 33.33 shares, 25%. Desired pool equals 15% of final total equals 0.15 times 133.33 equals 20 shares. Existing pool equals 10 shares, so add 10 more shares. Final split: founders equals 70 times open parenthesis 133.33 minus 33.33 minus 10 close parenthesis divided by 100 approximately 56.0 shares equals 42%. Angel equals 10 shares equals 7.5%. Option pool equals 20 shares equals 15%. Series A equals 33.33 shares equals 25%.